Hello students, welcome to your very first video of this school year. Today the title is 2.3 Solving Multi-Step Equations. Now please check Edmodo to make sure you know what page in your composition book you're supposed to be taking notes on, because I'll put it in the instructions instead of the video because it may change. So make sure that you're on the correct page, and because this is the first video of the year, I'm probably going to take a little bit longer because of some explanations that I'll be going through. Whatever you see me write on the board is what you need to write down in your composition book. Okay, so these are the notes that you're taking so that you can have them to go back to refer to later. Now, solving multi-step equations. I'm going to do a quick review at the beginning, and then we're going to throw something in there, curveball in there a little bit, to help you with something that is sometimes problematic, but not for you guys. You guys got this. So when solving a multi-step equation, that typically means there's more than one step. Multi-step. So I've got 11x minus 4 equals 29. Because I have 11x minus 4 equals 29, I don't want to start with the variable. I want to start with everything else that's with the variable. Okay? So I'm going to add 4 to both sides. And you're probably thinking, Mr. Collins, we got this, we've done this. No. Good. Well, let's finish it real quick. So then I have 11x equals 33, divide by 11, x equals 3, bam. Remember, multi-step equation. Got it? Great. Well, here's another multi-step equation that sometimes throws people off just a little bit, okay? So I've got 8 plus 7 divided by 8 equals 5, okay? So what do I do first? Well, we don't like fractions. Fractions are our friends, but we don't like them. So if we can get rid of the denominator, let's get rid of the denominator. So the way to get rid of the denominator is to multiply both sides by the denominator. So if I multiply both sides by the denominator, or 8, I'm multiplying by 8, I'm multiplying by 8. This is actually 8 over 1, and so those 8's cancel out, and so I'm done with that side, so all that's left is 8 plus 7, equals 5 times 8 is 40. Okay, let me just go over that one more time real quick. To get rid of a denominator, I multiply both sides by that same denominator. Okay, so I multiplied by 8 on both sides. 8 over 1 times 8 plus 7 over 8. The 8's cancel out, and they all become 1's. And then all I'm left with is 8 plus 7. Great. 8 plus 7 equals 40. Subtract 7 from both sides. So A equals 33. That's all. Just a quick review of solving multi-step equations. Sometimes solving multi-step equations includes finding consecutive integers. Okay, so let's break this down a little bit. Consecutive integers. Well, integers we know are negative and positive whole numbers. -5, -4, -3. There's no decimals or fractions involved. We're only dealing with negative or positive whole numbers, integers. Consecutive means they come right after each other. So an example of consecutive integers would be 2, 3, 4, or 7, 8, 9, or 853, 854, 855. Okay? So let's kind of talk about that. Let's pick an easy one like 7, 8, and 9. Okay? Now, let's say that instead of 7, I'm going to call this first integer n. N for any number. Okay? So n is my first integer. Well, if 8 is the second integer after 7, how did I get to 8? What did I have to do to 7 to get to 8? Yeah, you're right. We added 1. So what do I have to do to n to get to 8? To the second integer, second consecutive integer. To get from n to the second consecutive integer, I have to add 1. Not just plus 1, but I have to take the original integer, which is n, and then add 1 to it. So the second integer would be n plus 1. Well, what about the third one? Okay, so if I have 7 as my first integer, and my third consecutive integer is 9, how did I get from 7 to 9? You're right, you added 2. So in order to get from my first original integer, which is unknown n, to the third consecutive integer, I have to add 2. Not just plus 2, but I have to add 2 to the original integer. So the third consecutive integer would be n plus 2. Because I take that original number I add 1 to it to get to the second integer. I add 2 to it to get to the third consecutive integer. Okay? So I'm going to leave this up here because sometimes you get a problem like this, and I'll draw a squiggly. Okay? Find 2 consecutive integers whose sum is 45. Okay? Now I have to set up an equation in order to do this. Okay? Find 2 consecutive integers whose sum is 45. Well, the first integer is going to be n because that's the first integer. I don't know what it is, so it's n. Okay? The second integer we already figured out is n plus 1. Okay? So I have to add the first integer, which is n, to the second integer, which is n plus 1. So I've got the first integer n plus n plus 1, which is the second integer. Okay? Now what a lot of people want to do is just take n plus 1 equals 43. That doesn't work. Or 45. Okay? It's got to be the first integer, which is n, plus the second consecutive integer, which would be n plus 1. And that equals 45. Okay? So now, combine like terms. What's n plus n? Yep, it's 2n plus 1 equals 45. Now I'm back to a multi-step equation. I subtract 1 from both sides, and I get 2n equals 44. Divide both sides by 2. N equals 22. So if the first integer is 22, what's the second integer? I hope that was right. 23. Because my first one is 22, and the second one is 23. Now here's where a lot of people get mixed up. The question says find 2 consecutive integers whose sum is 45. You get n equals 22. Oh, I'm done. I found n equals 22. Woo, nice problem. Well, no, you haven't answered the question. The question says find 2 consecutive integers whose sum is 45. So you found that n equals 22, but that's just part of the question. Sorry, part of the answer. That's not the entire answer. So if the first integer is 22, then the second one has to be 22 plus 1, which is 23. So the final answer is 22, comma 23. Because my 2 consecutive integers are 22 and 23. And when you add them together, you get 45. The next part of this is still dealing with consecutive integers, but this time I'm going to say consecutive even or odd integers. Okay? So give me 3 consecutive even integers starting with the number, let's say 10. Okay? So if I start with the number 10, we're going to do consecutive even integers because 10 is an even number. Then the first one would be 10, and the next one would be 12 because I'm doing even numbers. And then the next one would be exactly 14 because I'm doing even numbers. Let's look at odd numbers. What if I just start with an odd number? Let's start with an odd number of, let's say 21. Okay, so if 21 is my first odd number, what's my second odd number? Consecutive odd number. That would be 23. And the third consecutive odd number would be 25. Okay? So, let's say I've got an unknown. Let's say that my first even or odd, it doesn't matter, integer is n. Well, how did I get to my second one? I hope you said it right. You added 2. Because 10 plus 2 is 12. 21 plus 2 is 23. So to get to the second consecutive odd or even integer, I have to add 2. So it's not just plus 2. I take the original integer n and I add 2 to that. So it'd be n plus 2. Now what about the third odd or even integer? To get from the first even number to the third consecutive even integer, I have to add 4. Same thing with odd. From 21 to 25, I had to add 4. So my third consecutive even or odd integer that's unknown would start with the n, because I got to start with my original integer, and then I add 4. Because to get from the first consecutive even or odd to the third consecutive even or odd, I have to add 4. So I've got n plus 2, n plus 4. The next one would be n plus 6. The next would be n plus 8. The next would be n plus 10. Okay? Those are the consecutive even or odd integers, and it works for either even or odd. And you might get a question like this. Okay? Find two consecutive odd integers whose sum is, let's say, 68. Okay? So I know I've got consecutive, and they're going to be odd. And there's going to be two of them. Okay? So we've got the first one and the second one. Well, the first one we know is going to be n. And the second one, because they're consecutive odd integers, is going to be n plus 2. So I'm going to add these because it says find whose sum, so I've got to add n plus 2, and we know it's going to equal to 68. Okay? The first integer is n. The second odd integer is going to be n plus 2, and the sum of them is going to be 68. So let's combine like terms. N plus n is 2n, plus 2 equals 68. Subtract 2 from both sides. So 2n equals 66. Divide by 2 on both sides. N equals 33. Bam, I'm done, 33. Well, no, you're not done, because it says find two consecutive odd numbers. So I know that the first one is going to be 33. What's the second one going to be? No, it's not 34, because that's not consecutive odd. I need consecutive odd, so I've got to add 2 to 33, and that's going to be 35. And don't you agree with me that 33 plus 35 equals 68? And those are two consecutive odd numbers, because 35 comes after 33 when we're talking odd numbers. Don't get confused when we talk even and odd and you're still adding 2 and 4, because those are even numbers. It still works the same way when we're dealing with odd consecutive integers or consecutive odd integers. So for this video, you have two practice problems. This is the most important part of the video, because this lets me know how much you understand from what you just watched. Now, if you need to go back and watch the video again before you do these problems, that's perfectly fine. You can watch it as many times as you want. But you need to do these practice problems in your notes, in your composition book, exactly where all the rest of the notes are. When you finish these practice problems, you're going to take a picture of them with your iPad camera and then submit that picture through Edmodo using the turn-in button. Okay, so here's your two practice problems. The first one is simply solve n plus 1 over negative 2 equals 15. Solve that, show me the steps of the problem, and then take a picture. Number 2, find two consecutive even integers whose sum is 106. Consecutive and even need to be your biggest hints in this. Okay, so do both of those practice problems, take one picture of both of them, submit that using the turn-in button before class tomorrow. Make sure you get it sent in on time. If you have any questions, email me. Otherwise, do these practice problems and make sure they get turned in on time.